Hi, welcome again to my YouTube channel. In this video, I will demonstrate how to use the K-means clustering algorithm for customer segmentation, grouping customers based on their spending patterns and purchasing behavior. So let's define the problem with a real-world example. Imagine we are working with a well-known shopping mall that wants to gain deeper insights into its customer. As an experienced data scientist, I can develop a system that segments customers into different groups based on their shopping behavior. For instance, one group consists of frequent shoppers who spend a lot, while other group includes customers who visit the mall but rarely make purchases. Identifying these groups enable the mall to implement targeted marketing strategies so as to improve customer engagement and sales. In my previous videos, I introduced classification and regression problems, which fall under supervised learning. However, customer segmentation is different. It is an unsupervised learning problem. So, instead of relying on labeled data, clustering algorithm helps us discover hidden patterns within customer behavior without predefined categories. So let's try to understand the workflow to complete this project. Our workflow starts with customer data, followed by data pre-processing to clean and prepare. We then conduct data analysis to identify patterns before determining the optimal number of clusters. Okay, we are using this elbow method where this W means within, C means cluster, S means sum of square. Okay, it is actually calculated, alright, by the Python itself. So do not worry about this. I will explain you further when we do the project. Okay. Next, what we do is we are going to apply the k-means clustering, and then we conclude with visualizing the clusters for better insights. Before we dive deep into choosing the right number of clusters in the k-means algorithm, we first have to know what is k-means algorithm? How does it work? What are some limitations of k-means clustering? Now the most important question is how to choose the right number of clusters in a k-means algorithm. Let's take a look at this scatter plot. After applying the k-means algorithm, the result looks like this. Well, the question is, why is it just 3 clusters? Why can't it be 2 or even more, which is 4? Do you want to know the answer? Stay tuned. In order to answer this question, let's analyze the sequential steps of adding the centroid. So according to the above graph, we can analyze the substantial change in the value of WCSS by adding 2 centroids from 1 to 2. Again, see the abrupt change. And by adding 3 centroids, you can see that there is no abrupt changes. just as a small differences observed when you add more centroids, isn't it? So this is the optimal number of clusters, which we call it as elbow method. Okay, so to understand all these things better, let's do this project together. Okay, so I'm using Google Colab to do this project of this k-means clustering. Okay, so the first thing you have to do is just to import the dependency. Okay, maybe this is, sorry about that, yeah, I just give a text over here. So I will start with importing the dependencies. Okay, so as we know, this dependency is very important. You're importing the library so that we can use it later on. Okay, so import numpy as np. Okay, this is very important for arrays especially. And then import pandas as pd. I think if you go with all my videos before, right, you will have known what all these functions is about. And if you not, just comment it and I will tell you which video you can refer to. Okay, so yep, in this case I'm not going to use all this sklearn model selection or linear because it's not under linear okay model. So I'm going to just import matplotlib dot py plot splt. This is basically to visualize it into graph and make it a better graphical visualization. And then I'm going to use import seaborn also, the same thing for visualization of the data. And then this time I'm going to use, yes, I'm going to use sklearn, but this time remember we're going to use k-means, right? So it's not linear, but this time is sklearn k-means, okay? So I'm going to write sklearn dot cluster. Remember, k-means is k, right? K is, I do not know why it's not C, but it's K. It's like meaning cluster. Okay. So sorry for the wrong spelling here. SKL. Then alright. So let's run this, and that's it. Okay. So now let's do the title again. And this one I'm going to do data collection and analysis. Okay. So what I'm going to do, basically I'm going to make use of what I've import here, the pandas, right? So let me first give the command, right? So here is importing the data frame or the data from CSV. Okay, from CSV file to pandas data frame. So that's the reason why we have imported this package, the library here. Okay, so I'm gonna do what is my importing capital letter. Okay, just doesn't matter actually, but I just make it to look nicer. Yeah. Ah, great. It already typed for me, right? Type. Actually, I have already uploaded the file, which is known as small.customer. Okay. If you want the file, it's at the link description below. You can just click it and download it. Okay. So, yep. Once I have upload this file, you just click this and upload the file, and you just this um set of lines, okay, the coding, and run it, and that's it. It will work. Okay, once it says a tick, it means it works. Okay, just going to remove this number 3. Now what's next? I'm going to show the first 5 rows. So let's code again. That's the reason why we use pandas, right? This is all the purpose of importing the package pandas. Okay, so first 5 rows in the data frame want it to be shown. So what happened is that I just, yep, customer data.head, that's it, and run it. Yeah, as you can see, this is the very first 5 of rows of the data. Okay, so you can see it has customer, gender, age, annual spending score. Alright, great. So maybe I want to understand how many columns that is, right? Because this is just showing the first five, right? 0 to 4 means the first five columns. What about if I want to know more details, like how many uh, columns there are in this data set? Okay, if there's a lot, I couldn't just like print everything, right? It will slow down my process. So let me just give a comment finding the number of rows and columns. Okay, so what I'm going to do is that I'm just call upon the name of data. How we start before me. That's great. This Google Colab is so fast. Okay, so they will show me how many columns I have, and rows is 1, 2, 3, 4, 5. Yep. Just customer ID, gender, age, annual income, spending score 1 to 100. Great, and it has 200 columns. Okay, so at least I know exactly a little bit about this data set. Right? If I want to know more, which one maybe this gender is a string, or this age is not even a what do you call a numeric a column, it is just a text. So I need to check this also. Okay, so I'm going to get more information, right? So getting uh some information about the data set. Okay, so what I'm going to do is just customer. Yep, that's it. Info. So this will tell me more. So we know that customer ID is integer, which is numerical. Gender is an object. Okay. Alright, great. So we know that this is also classification that we can later convert it to binary, like male is 1, female is 0, for example. Okay. And age is an integer, perfect. Annual income and spending score is also integer. Alright, that's great. So we know more about this data set. Next, maybe I want to know if there is any null values, which is, if there is, I definitely have to clean it up, right? So first, I have to check if there is null values or missing value. So the checking for the missing value. Okay. Um, so how to do it? You just call upon the name of the file. Yep. Submodel is null.sum. So that's it. You run it. Great. So this data set doesn't have any missing values. Perfect. Okay, great. So now we're going to look again at the data set. Okay, and identify actually which columns do we need for clustering. Basically, we are going to group customer based on their spending behavior, right? So definitely spending score is important. So we need this. Customer ID, no, I don't need customer ID to group it. Gender, maybe, but it's not really important, I guess. Age also, you can do that if you want to, but in this video, I'm just going to focus on the annual income and the spending score to group based on the spending behaviors. Okay, so okay, let me create a title first over here. Okay, so I'm going to set choosing the annual income column and what else? The spending, right? The spending score, I think. Let me see. And the spending score, yep. And spending score column. Okay, so how to do that? Just do the code. So you just go, I'm going to create a variable. I'm going to name it X. Okay, so X is going to be the customer data that data before me dot ilog. Ilog means integer location. Okay, so we have to identify where this annual income and spending score is located. Okay, so the integer location is from here, right? It's type customer ID is 0, 1, 2, 3. Okay, so annual income sits at 3, and over here the location of spending score at 0, 1, 2, 3, 4. So it's 3 and 4. That's the reason they type here 3 and 4. Okay, so this is what I want them to the X to be. Okay, I'm going to name this annual income and spending score columns as X. Okay, okay. If you can't see really, right, you can just print it. So if I print X, then you can see what I mean, right? So let's run this. Yep. So you see, I'm just exporting only these columns that sits in location 3 and 4. Okay, which is the annual income and spending score. So for example, right, the first one is 76 and 40. Yep. So here is the annual income is is 15 and 39. Let me see again. Oops, did I? Yep, correct. It's 15 and 39. Yeah. So 1539, 1581. Okay, let me just see the last one. 0, 1, 2, 3, 4. So the fourth column is 70, 40. So fourth column is 70, 40. Correct. Third column is 1677. Okay, third column is 1677. So this is perfectly fine. Okay, so okay, this is what I mean by okay, I want to just select the column of income, annual income column and spending score, and I'm going to name it okay as X. I'm going to make a variable called X so that it will store it okay and remember it. Alright, okay, so the next step is to choose the correct number of clusters, right? Remember I've done and showed you, maybe you can rewind back. Okay, maybe I will show it to you more what we have done and explained just now, right? Let me show it to you. Okay, remember that I have explained to you what is the function of WCSS, right? So I'm not going to go into detail, but I'm going to show it to you, the applications here in this project, okay? So basically we are going to use this formula to identify how much clusters is it needed in this data set, because every data set requires a different number of clusters, okay, and which we do not know. So for example, if this is centroid, right? This centroid is only have one cluster. It means that it is not good because the WCSS is very wide, very huge, very high. Okay, from the clusters. You see, this is the centroid, and the clusters distance from the centroid is very far away. So this is not good, right? But if you were to create another cluster, okay, which is cluster 2, see this C2 is not so far from the cluster, right? But even we can refine it further, making cluster 3. Okay, so the distance between the clusters and the centroid is much nearer, okay, so much lesser the distance, so which is better, lower value, right? But in this data set we do not know how many clusters we need. That's the reason, alright, we need to perform this WCSS and to use this elbow method in order for us to find what is the optimal number of clusters. Okay, got it? Alright, so without further ado, let's jump back to this Google Colab and let's begin our journey using this WCSS for you to understand even better. Okay? Okay, so let's do this WCSS here. Okay, so let me just create a text. So I'm going to write maybe the title, choose the number of clusters. Okay, so as you know that WCSS is for us to use in order for us to know how many clusters to be used, right? So just put the title, choose the number of clusters, and then maybe yep, that's it, and I just put code. Okay, for those who still do not know what is WCSS, okay, maybe I just put it here. Okay, so um WCSS, what it means, okay, try to comment below, okay, if you remember. Okay, what this WCSS means, it just mean within clusters, sum of squares. Okay, so that WCSS means. Alright, so what I'm going to do is I'm going to find the WCSS value for all the different numbers of clusters. Okay, so to know that what is the lesser number of cluster, I mean lesser number of WCSS, because the lesser it is, the better it is, right? The the higher it is means it's very far from the centroid, right? So we have to find which one is the lesser from the centroid. Okay, so let's try to find. Okay, let me just comment it. Finding the WCSS value for all the different clusters. Okay, value for all the clusters lah. Okay, for all the clusters. So what I'm going to do is I'm just going to name a variable as WCSS equals to, and this is empty list because I do not know yet the number of WCSS, so it's going to be empty list, right? And I'm going to specify, sorry, this I've done already, that's why it's auto. Okay, but I will explain to you. So for I in range 1 to 11, okay, this is a loop, which means it's going to run first the range from 1 to 10, because I want to make these clusters from, just now I've explained, right, from 1 to 10. Of course, if you want to make the 1 to 50, 1 to 20, or 1 to 50 is fine, but 1 to 10 is the normal one, and is usually used and it's more productive, like, rather than you make it more, right? So I make a range 1 to 11. 1 comma 11 means this is 1 to 10. Okay, so what happens is that I create another variable called k-means, and I'm going to call this k-means variable using the function that I have imported just now, right? Earlier I imported the sklearn k-means, right? If you notice this, sklearn, sorry, cluster import k-means. So I'm going to use it here. Okay, alright, I'm going to use it here, but I call this a variable so that is able to store, okay, the value of whatever it has created from the k-means and cluster, which is, what is the clusters from 1 all the way to 10. Okay, so I in the range of 1 to 10, right? So is I, okay, whatever is the n cluster will be the value of 1 all the way to 10, and initiate the k-means plus plus. Basically, I use k-means plus plus instead of just k-means because so far in k-means clustering, I believe k-means plus plus is the best. Okay, and then also I'm going to use this random state 42 because this is so normal. I do not know there is a history behind this number 42, which you can actually Google it, okay, to read about that. But in scikit-learn, what it means random state is just the controller shuffling applied to the data, okay, before you applying the split. So, you know, we use it like train, test, split, right, for splitting data into training and testing data set. So this one, if you give a value of 42, basically, instead of null, if you will say null, if you don't specify the number, right, it will just like produce different results in every of the execution. But since you stated it as 42, so it will execute always the same value, okay, for 42, which is 42. Okay, so that is what it means by random state. Okay, then k-means fit. So once you have done this part, right, the k-means whatever in the library they have done this clustering of the k-means, you're going to fit it inside the X. What is the X? This is the X. Remember, we have choose the column annual income and spending score. So you're going to fit this k-means inside this X. Okay, so whatever the X is inside, you fit it into the k-means. Alright, so that is what it means here. Then if you run, of course, you cannot see anything, so you got to plot in order for you to see which is the best cluster. Okay, so oops, okay, yeah. I'm going to just maybe comment it as just plot the elbow graph. Remember, I've also explained to you what is elbow graph. Okay, so elbow graph, you can see the graph that will show you which one is the best clusters, okay, that you can use. Alright, so let me just try to plot it using sns.set. Okay, so um, plt.plot. Okay, great, they already typed it for me. So basically, again, you're going to plot from range 1 to 11, the same as I've mentioned here, range 1 to 11, which is 1 to 10, okay, and which is WCSS, which is this, okay, whatever that fit inside this k-means x, okay, is going to be this now WCSS. Okay, but before this, I forgot, sorry, yeah, I forgot one more step. Yeah, this is the step. Basically, I have fit this k-means inside this x, right? But I haven't put it back inside this variable, so this variable is still empty. So I'm going to append, okay, so whatever the results after fitting it into x is going to append my WCSS here. It's no longer to be empty, but whatever results, right, is going to be um, the inertia will be the k-means inertia will be appended to be inside here, okay. Then I'm going to plot this. So when I plot this, okay, there is an error, maybe because I didn't run this after I add this. So let me run this again, and then I run this. So let's see what happened. Yep. So you can see the elbow pointer graph. So can you see from the elbow pointer graph, if let's say it is 2 cluster, from 1 to 2 cluster, or 1 to 4 cluster, okay, or even 1 to 3 cluster, it has a lot of you know abrupt changes, right? So it's not good, right? That means the distance between the centroid and the cluster is too wide, okay, and it is like abrupt. And even from 2 to 4 is quite abrupt. But here the point onwards, right, from this point is a bit consistent, not so abrupt, right? So I think 5 will be a good cluster, right? So this is what I mean when I use this WCSS. Okay, so I hope you are very, very clear with this WCSS. If you're still not clear, please comment below. Okay, maybe I can explain it better in another example or whatever. Okay, so now the next step that we have to do. Okay, so now I have known the optimal numbers of clusters, right? So what I'm going to do is that, okay, let me just use the text. Okay, optimum number of clusters. Okay, I'm going to use 5 because I find that this elbow point of 5, okay, does not have a lot of significant drop, okay, comparing to like 1 or even 3, right? Now 4, it has a little bit of, yeah, a very high drop, yeah, a very, very significant abrupt drop, okay. But 5 onwards is like very slight significance of changes, right? Okay, so there's not much abrupt changes. So I will use this elbow point of 5, okay, to train the k-means clustering model. Okay, so I'm gonna say training the k-means clustering model. So what I'm going to do now, let me code it. Let's see. Okay, so again, I'm going to use this exactly like that. K-means all this. You can copy if you want to. Just Control C, right? Control V. Okay, I'm going to use this k-means, but now no more cluster is equal to I because I've specified the optimal number of clusters. I've known it to be 5. So I'm going to change this I to be 5 instead. Okay, and the initiate k-means plus plus the same, right? And then after that, k-means fit x, right? But now I don't want this k-means to be not known anymore, I'm going to give a variable. Sorry about that, yeah, Control C. So maybe I'm going to call another variable called y equals to k means accident, yeah, k means fit x. Okay, because I want to print the y and you can see what happened, yeah. Over here, what I mean by that is that, as you can see, there is like 200 over data sets, right? No, where is it? Yep. There is like 200 over data sets, right? The columns 200 over. So when you print this income column and spending score column, alright, what you did over here, right? Oops, let me just go down over all the way down here. Oops. Okay. So what I'm going to do is, right, I'm going to see what will it be labeled, because currently everything of the data here is not labeled yet when you clustered it. So once you have done the k-means training, right, you still do not know what will it be labeled. The cluster 1, cluster 2, cluster 3, whatever things is not being labeled. So I want it to be differentiated, right? So okay, let me just print this and you will see. Okay, k means clusters, cluster 5, clusters random 5. Okay, so k means dot fit predict x. K means y is equals to k means fit predict. This time I'm going to predict. Sorry about that. Now I'm going to let it predict. Okay, so okay, now it's going to predict for me that this cluster is going to be labeled as from 1 all the way to 4, because there is a 5 cluster, right? So 1, 2, 3, 4. Of course, it's 0 also. Okay, so 0, 1, 2, 3, 4, consider it's 5 cluster. Okay, so whichever that is fitting this x, okay, this value of x, which is the annual income with the spending score, right? So it's going to fit for me and it's going to be clustered and label it by 0 to 4, 0, 1, 2, 3, 4. Because when you do this, right, you know that it's unlabeled. All this is unlabeled, okay, which is unsupervised. Now you're going to supervise it with labeling it from 0 to 5. Okay, I'm going to show it further so that you understand it better, okay. Let me just do the text again. So you know that the 5 clusters now is named into 0, 1, 2, 3, 4, right? So it has 5, 1, 2, 3, 4, 5. Okay, but it's always start with 0, so it's not like 1, 2, 3, 4, 5 like start 0, but still you know that this is 5 clusters. Okay, so now I'm going to visualize it so that you will be able to understand it better. Okay, so let me just put a title, visualizing the cluster. Visualizing the cluster. Okay, so let me just do the code now. Okay, I'm going to plot the clusters and the centroid so that you will understand it better, yeah. Plotting all the clusters and their centroids. Okay, so this will make visualization is always the best, right, for every people to understand things better, right, rather than just numbers like that. Okay, so what I'm going to do, I'm going to plot the figure size. Okay, plot figure and give a size, maybe the figure size. They give me 8 to 8. Okay, leave it to 8 to 8, it's fine. And since I've done it before, so it's automatically did it for me. Don't worry, I will explain to you. Okay, PLT scatter X. What is X? Remember, X is the sign, okay, which is the annual income. Okay, annual income, which is under the 0, okay, column, and this is like array, right? So this is 0 and 1. Okay, so annual income column is 0, spending score column is 1. Okay, so all this is, oops, can't even, okay, all is 76, 77, 78, all this is 0, 40, 87, 12, and so on is 1. Okay, so over here, all right, if you were to see this x, okay, is saying the annual income, which is 0, and x over here is referring to the spending score, which is 1. Okay, and over here y is equals to 0 is referring to this y. When you print y, right, this is the y, so this y is 0 is referring to the clusters that is 0. Okay, all the cluster that is 0. Okay, so this cluster 0, I want it to be labeled as cluster 1. Okay, and I want it to be changed to color green. So when it's cluster, all these annual, what do you call it, annual, what is this, annual earning, is it annual earning, what is it called, tend to forget, annual income, sorry. Okay, so all this, the annual income will be grouped together in cluster 1 and it shall be green color. Okay, and the one that is the spending score of um, those in those spending score in 0 will also be in green color. Okay, so I'm going to repeat this. Okay, and maybe when you visualize it, you'll understand better. Okay, so I'm just going to control V. Okay, so over here, all right, I'm going to change this. Okay, now the x here is going to be 1. All right, and here also will be no more 0, but it will be 1. Okay, this annual earning 0, 0, right, and the 1, 1, which is the x of the spending score remains 0 and 1. This one doesn't change, but the cluster of y equals this one has to change. It will become 0, 1, 2, 3, all the way up to 4. Alright, you got it? Okay, s is equal to 50. This is just the size of the marker. Okay, doesn't matter. Okay, later on when you visualize it, you'll understand it better. Okay, so I'm just going to paste it again. So instead of 0, 1, then now is 2. Okay, and this one also becomes 2. Okay, okay, and again, okay, of course I'm going to change the cluster name also lah. Okay, so this is cluster 1, the 0, right, in y becomes cluster 1, the 1 in this y become cluster 2. Okay, and the y which is 2, alright, y which is 2 will become cluster 3 and so on. Alright, so let me just, I think I need 2 more, right? So I'm just going to control C and let me paste control V. Oops, doesn't work. Control V. Oh, what happened? I didn't copy, is it? Okay, let me just control C and again control V. Okay, great. So now it's 0, 1, 2, and here is going to be 3, and here is going to be 4. Okay, and here also the same thing, 0, 1, 2, 3, and 4. Okay, again I repeat, this 0, 0, 0 is all the x, which is the annual income, and this x for all 1, 1, 1, 1, 1 here is for the what? The spending score. Okay, it's just the y here I need to change because this is the y that I need to group it based on the cluster. So for 0 it becomes cluster 1, 1 it becomes cluster 2, 2 becomes cluster 3, okay, 3 become cluster 4. Wait, 1, 2, 3, 4. Okay, and the last one, which is 4, I want to name it as cluster 5 because we have 5 clusters. So this one, for human is easier, right, for us to visualize. Okay, when I run this, you will not see anything. I mean, yeah, you get to see things lah, but it's not really like, hey, all green. Okay, I have to change like the colors because it's confusing. So maybe green and then red, maybe what are the colors Yellow, okay? Maybe yellow. Okay, what else? Maybe blue, okay? Or violet. Okay lah, and then what other colors? Maybe blue lah, okay? I cannot think of any other colors. Blue, okay? So blue. So let's see. Alright, can you see that? It has all been clustered accordingly. So those in, let's say, for the spending of X, right, over here, which now we could actually see, okay, it has been clustered by colors. But the problem is we do not know, right, which one is which one, meaning that mm, which is the annual income and which is the spending score, right? So to make it even neater, okay, I think it's best we also you know try to see and show the centroid. So at least you know the centroid, right? The centroid is the the center of all the cluster to see that how far the centroid is from this cluster. If it's near, not too far, means it's good. Okay, so I cannot add another code here. Let me just continue from here. Just plus plus. I mean just enter enter. Okay. So maybe I plot the centroids. Okay, plot the centroid. So every cluster has a centroid, so we can see the distance of the centroid from the cluster itself. So okay, so plt dot scatter. Okay, they type it for me. I just tap it. Okay, so this one is just the k-means cluster center because we are going to make it to show the centroid, right? So it will be in the center of the cluster. So K means cluster center. Okay, so what it means 0 is just the x-axis, the x-axis starting from 0, in this case x-axis, and in this case the K-mean cluster center, this is the y-axis. So maybe the x-axis is 0 and the y-axis is 1 in this case. Okay, so that is all what it meant basically. So for the S is equal to 100. This is just the size of the centroid. Currently, if you can see this cluster, the, the cluster points, right? The size is 50. So if I put the centroid size to be 100, it will be much bigger than this cluster. Okay, let me just try to play it and you can see. Can you see that? They draw for me the centroid now. This is all the cluster. Okay, starting from is it the x-axis, okay, it's around 20 something. It's like starting always from the 0 of it, okay, and 1 of the cluster is from 0 to 1. Okay, that is what it means, 0 to 1 of the x-axis. So basically if this is the scatter plot, right, I mean this is all the scatter plot and this is the what do you call it, the cluster. So you always start from the middle 0 and from 0 to 1, like 0 to 1, 0 to 1. Okay, so the size is bigger, is 100. If you put even like maybe 200, you even go so much bigger. Okay, let me try to show it to you. Yeah, so much bigger, right? So I don't want 200 lah, so funny. So I just make it 200, just at least half of, oops, 2100, at least half of the size of the cluster. Okay, so I just put 100. Okay, so this is how it looks. All right. But basically you notice, right, you do not know which one is either the x-axis and the y-axis is which one is for which one is the annual income and which one is the spending score. So it's good also to have title and also to have a label, right? So let's make the title. So yeah, great, it makes for me. Maybe the title is the customer groups because it's segmentations of customer, right? You can put customer segmentations also, it's okay. All right, then PLX label is the annual income. So this is going to be the annual income and Y is going to be the spending score. Let's try to run and see. Yeah, so this is how it goes. We can see from the data visualization, right? Those who has a lesser annual income, they tend to spend lesser. Those who has a middle annual income, they also spend middle. And but this part, right, is a bit weird because you can see those who has less annual income, but they still spend a lot comparing to here. Okay, so basically how we can push these people who has low income but still be like this yellow color to spend a lot. How maybe we can start to promote or maybe make discount, you know, make a sale that is like, lesser. I do not know, maybe mm, more discount, more saving, that kind of thing, so that to boost these people who low income to know that hey, even though it's this mall is selling things but it's a discounted rate, so it can push them to become like this yellow uh segments or yellow cluster, right? Where even though they have small income but they still purchase because yeah, this is one of the maybe the methods. Okay, and over here you can see that those with high income, this is also high income. One high income tend to spend a lot, but here high income but didn't spend a lot. Maybe they are very very cautious. Even though they have high income, but they're not spending so much. They're very very cautious of what they're spending. So how to boost these people? Maybe I don't know. Maybe try to um ask them to subscribe, get some membership, push them so that if you have this membership you can keep buying things at better pricing. So I do not know, this is all the strategies that can be done by the marketing teams, right, by looking at this data. So I hope you have enjoyed this video and learned something. Okay, please comment below, and if it's really really beneficial for you or not, please just comment on it. Maybe I need to improvise anything else, so just comment, feel free to comment, and please share the video too, alright, and subscribe and like it. Thank you so much, guys.